density. Density is D, and density is going to be mass over volume. Mass divided by volume, like so. And shorthand, M over V. Now I've got some densities over here, and let's see, yeah. One density that's important to remember is going to be the density of water. So I will box that. And it's giving the density as in units of grams divided by centimeters cubed is going to be the number 1.00 and the units grams per centimeter cubed. And then I'm also going to write it with a different set of units. I'm going to write it as 1.00, same number, grams per milliliter. And these numbers are the same because 1 milliliter is defined as 1 centimeter cubed. So another way of saying that is 1 milliliter equals 1 centimeter cubed. And different metals tend to be more dense than water, and many liquids, though not all, tend to be less dense than water. So ethanol is a liquid. And all of these, yep, all of these are metals. So the metals with a higher density than water will sink in water. So that's what density is. Now let's do a calculation of density. It says a lump of metal has a mass of 215.8 grams and displaces 19.1 milliliters of water. Identify the metal. So D equals mass over volume, M over V. Our mass is 215.8 grams. Our volume is 19.1 milliliters. And I encourage you to bring your calculator to these lectures because we'll always be using it. And so 215.8 divided by 19.1, I get the answer 11.29. I'm going to just write it to 3 digits, 11.3. And this is important. Almost all numbers in chemistry have units, and I is very much. And now in my course in particular, after you do a calculation, you always want to go back and reread the question to see if you've answered it. I haven't answered this question yet. It says identify the metal. Now I have to go down here and say, well, the density of lead is 11.3, so the metal is lead. Okay? The metal is lead. So that's our first calculation. This problem is what's called a companion problem. And companion problems, the abbreviation for a companion problem is capital CP. So companion problems are additional practice. That does not have to be done when you turn in your lecture outlines. You can leave these pages blank or leave them out, so don't take the PDF of them. The only reason, and I think there's a very good reason to do it, but the only reason to do this problem is if you need practice to make sure that you can do a density calculation. But you do not, that practice is optional. So when you do the lecture outlines, You do not have to do these problems. I suggest that you do the problems, but you don't have to, okay? And you'll see that one of the things I try and do is whenever there's a problem, a lot of times there will be companion problems to work as well. So we don't do that one. Now let's talk for a few minutes about units. There's a set of units that I'm showing on this slide that are typically what we use in this class. And let's see. Yeah, so I don't think there's anything else really to say about this other than these are the typical units, and almost everything we do is in these sets of units. So no notes. We also have a bunch of prefixes, and these you will have to memorize. And in particular, I'll tell you the most important ones to memorize. So kilo, centi, milli, micro, and nano. Those ones show up a lot in problems. So if you know what they are, it'd be really helpful. There. So those are the ones you have to memorize. The other ones, every once in a while you'll see a pico, like a picoliter or a picometer show up, but it doesn't happen as much. Question, how do you identify companion problems? As I go through the lecture notes, I will identify them for you. Okay, and hopefully that answers your question. So, and I'll write CP right on them so you know they're companion problems. The other way you identify companion problems is you'll see two problems that are similar. The second one's usually a companion problem, though that's not always how it works. Okay, so now we are at a very important part of the course. It's day one. They are conversion factors. We will do 200 plus conversion factors and maybe 300 plus in this course. So identifying and knowing how to use conversion factors is very important. All a conversion factor does mathematically is it changes one set of units into another set of units. And examples of non-chemistry unit conversions are going to include statements like this. So 100 centimeters equals 1 meter. This is what's called an equals statement. And that's a little arrow pointing to this. So this is an equals statement. That just means there's an equals sign in it, and it tells you two things that are equal to each other. Two things that are equal to each other. And so like 1 week equals 7 days. That's one we're probably pretty familiar with. 1 gallon equals 128 ounces. Yeah, maybe we have an idea about that, but we have to Google it to look it up. 100 centimeters equals 1 meter. That you can look at a meter stick to find. What we need to know is that any two things that are equal to each other can become a conversion factor. And let me show you how that works with this example. And this is an example of a non-chemistry conversion problem. How many gallons is 26.7 ounces? Well, our process for doing this is, okay, we start with what's called the given. The given is a number in the problem. that we start with. And the given here is 26.7 ounces. Okay. And what I'm going to do is I'm going to draw like a little plus. Once we get more to later problems, you'll see that this is what's called the picket fence, because it can have multiple pickets in it. And it will, well, it's also called the railroad tracks. But it's my approach to solving unit conversion problems. Now, the unit conversion problem that we need is based on this equal statement. It says 1 gallon equals 128 ounces. And to turn that into a conversion factor, I turn it into a fraction. So, and this says 1 gallon, there is 1 gallon per 128 ounces. Or there are 128 ounces per gallon. So these two things down here are my unit conversion factors. And that just means that when I put them here as in a fraction, that they will change my units. That's what a unit conversion factor is. Okay, so we have two choices. We have this one here to the left or this one here to the right. We choose the one that we want based on the fact that the units will cancel out. So that means since I have ounces on the top, I need ounces on the bottom. And I'm going to use this one that I just circled. And it says 128 ounces equals with on the bottom and 1 gallon on top. And then I say it's equal. And then to solve the problem, I multiply by all the numbers on the top. I divide by numbers on the bottom. Multiply numbers on the top, divide by numbers on the bottom. I lost a little bit of the page there. There we go. And so using my calculator, I have 26.7 times 1, so we don't have to do that, divided by 128. And I get 0.20, well, you see all these numbers on the calculator? We're only going to write down 3 actual numbers. So 0.20, and that 8 is going to round to a 9. 0.209 gallons. And that is our first unit conversion problem, one of over 300 we will do this semester. So excited, I know. All right, any questions about that? Okay, well, 299 left to go. So here's another unit conversion problem. It says convert 96.2 millimeters to meters and kilometers. The number in the problem is going to be the given, 96.2. And those are millimeters. And if I go a couple pages back, or I have it memorized, I can see that 1 milligram equals 1 times 10 to the minus 3 grams. We can also say 1 millimeter equals 1 times 10 to the minus 3 meters. Okay, so that's my equal statement. I want to turn it into a unit conversion factor. That means that those two things are going to go above and below each other. I want my millimeters to cancel out. So of the two things, I put millimeters on the bottom. I want units of meters. I put my meters on the top with the number that goes with them. And now I have just converted my units, or I've set it up. Now we have to do the actual calculation. Now, using your calculator, I got a question earlier, do we need a TI-84 calculator? No. All that's important is whatever calculator you get, you know how to use. Question, are these companion problems? No. These are, so let's say this. Now I understand your question. How do you identify companion problems? Companion problems are the ones that I don't do, and companion problems are the ones that I write CP next to. So we will not do this one in my lecture. You don't have to do it and write it in your lecture outlines when you turn them in. So basically anything I do, you have to do. Like that's, if you're looking for a short answer. All right, so can we include companion problems in our lecture notes? Yes, that would be great because that means you're getting additional practice. Yes. Do I have this video pinned? Oh yes, it's spotlighted, good. All right. Okay, so you have to know how to use your calculator. So 96.2, that's no problem. Now I need to multiply times 1 times 10 to the minus third. On my calculator, I enter that in by entering 1, then hitting the exponent function, and that gives me, oh shoot, let me try that again. So 96.2, I got a little carried away there. So first I have to do the times button, then I enter 1, exponent. I don't enter times 10 to the, I enter 1 exponent, then I enter 3, and then I hit the plus minus button right here, and it puts a little minus. So 1 with an minus 0.3, that is 1 times 10 to the minus 3 on my calculator. And if you don't know how to enter in exponentials on your calculator, please come to an office hour and we will work through it together on your calculator because that's an important part of this class. Anyway, now I hit the equal sign. I get 0.0962. And those are units of meters. And sometimes what I like to do is I like to cancel out my meters, my millimeters clearly so I know what my units of my answer are. Now, we're going to have companion problems in exams. No, but you will have problems on your exams just like them. That's why they're so useful to do. Good question. Okay, so we just did another unit conversion problem. Now let's finish this problem because we also have to convert it to kilometers or kilometers. I have meters, so I'm going to start with this now. And I have memorized that 1 kilometer equals 1 times 10 to the plus 3 meters. And again, I can cancel my units out. And this time, I've got to divide by 1 times 10 to the plus 3. So 0.0962 divided by 1 exponent 3. And of course, I don't hit the plus minus sign now because I just want it as 1 times 10 to the plus 3. And I hit my equal sign. And I get 9.62 times 10 to the minus 5th. And I get units of kilometers or kilometers. Okay. So that's and you'll see homework problems just like this. It will ask you to convert units and then enter your answer into Blackboard as well. Let's do C. C says convert 10 centimeters squared to millimeters squared. The number in the problem is our given. For my given, I'm just going to write G now. G, 10.0 centimeters squared. Now I need a unit conversion. And I'm going to do, so I know that 1 centimeter equals 1 times 10 to the minus 2 meters. And I know that 1 millimeter equals 1 times 10 to the minus 3 meters. And I'm not done yet, but that's my setup so far. Now, nobody's asked yet, but I'm going to tell you, I'm going to ask the question, do you have to do the problems in exactly the same way that I do them? And now I will answer that question. No, you don't have to do them in the same way at all. If you have a better way of doing this problem, and I would suggest there is an easier way, if you have memorized that 1 centimeter equals 10 millimeters. Like then you could do this in one step. And doing it in one step is fine. All I will ask is that when you have, when you turn in work to me, whether it's on homework, an exam, quiz, or whatever, that if the so that you always show work. So I should be able to go to your problem and tell how you do it. It doesn't have to be the same way I do it. In fact, you should do it the way that you think is best. And so let's say after this lecture, you still don't know how to do conversion problems, or you want more practice, and so you go to Khan Academy. I like Khan Academy a lot. They do some great videos. And Khan Academy does it in a slightly different way, or even a totally different way than I do. And you like Khan Academy's way. Great. Do it Khan Academy's way. Do it my way. Do it the way that your tutor or your study group mate does it. Any of those ways is fine. Just make sure you can show your work. So, but we're not done here because I have centimeters squared here. And I only have centimeters, so that doesn't cancel all the way. So here's what I want to show you about this. So this right here is a unit conversion factor, and it's okay, and it doesn't happen often, but it's okay to square unit conversion factors. And when we do that, this is equal to saying 1 centimeter squared equals 1 times 10 to the minus 2 meters squared. And it's a little harder to enter into your calculator, but it does come up often enough that I want to cover it. And then for this one, we also want to square it. And this is like saying 1 millimeter squared equals 1 times 10 to the minus 3 meters squared as well. Okay? And we're going to need our squared button quite a bit in this class too. All right. So now, how to do this on your calculator? Well, there's the last problem. First, enter in 10. You can enter in just 10, or you can enter in 10.0, but the calculator just thinks it's 10 anyway. Now on the top, I have 1 times 10 to the minus 2 squared. So let's do 1, hold on, did I enter in? No, so multiply. 1, exponent button is times 10 to the 2 minus. And then I have my squared button up here, so I'm going to hit squared, and it squares it for me. Now I'm going to hit divide by 1 exponent 3 minus squared. And my answer is 1,000. And my units are, well, my centimeter squareds cancel out, my meter squareds cancel out, and I'm left with millimeters squared. I know, that's fancy math, but we do see it from time to time, and so I wanted to show it to you. 90+% of the time, we do not square conversion factors. In fact, I'd say 95+, but I want to make you aware of how to do it. Down here, we have another companion problem, CP. Let me put the whole page on the screen again there. And now let's start talking about significant figures. We'll start significant figures anyway. I don't know if we'll finish them before we take another break. Significant figures is a system of rules for reporting measurements that communicates how well the value has been measured. A, always report all of the digits for which you are sure of, plus one more that you have some information about. And we're going to talk about this a lot in lab, and we're going to talk about it a little in lecture. But what I've got is I've got a picture of a graduated cylinder. A graduated cylinder, where graduated means with markings. Right? We all hope to be graduated someday, but in a different sense, not in the sense that it means with markings. So it means with markings, and you can see the markings on this graduated cylinder, and I've even got a close-up here. And one of the things I want to show you about this close-up is what's called the meniscus. And the meniscus is this curved interface of the water of the water. The curved interface of water. And when you get to lab, whether it's this class or any other class, you always read the bottom of the meniscus. Always read the bottom of the meniscus. Hold on. Okay, so let me change that just a tiny bit to always read the center of the meniscus. Sorry about that. The center of the meniscus. Meniscus. And it just so happens that 99% of the time, the center of the meniscus is also the bottom of the meniscus. "99% of the time, the center is the bottom. And so it was tempting for me to write that, but technically the way to read the meniscus is always in the center. And so if we were going to read this meniscus, we would read it right at the bottom, and you would see that this bottom is at 8, 8.1, 8.2, 8.3, and it's a little above 8.3. So the reading is 8.3 for sure, and then it's going to be 8.32, 8.31, 8.33. This last digit is the digit that we're not sure of, that we're sort of guessing at. And so any of these measurements, if you were reading this graduated cylinder, would be fine. And just so you know, these are milliliters, so they have to have units. There we go. So what I mean by always report all of the digits for which you are sure, we know it's 8.3 something. We are, then we're going to report one more digit that could be a 1, a 2, or a 3. Okay. And when we get to lab, I will show you pictures like this, and I will ask you to read correctly what the volume is in this case, based on where the meniscus is. Now, how to count significant figures, which I call sig figs. All non-zero numbers are significant. So when I see a 2, 4, 1, 8, there are 4 numbers, and those are what I'm calling 4 sig figs. The 2, the 4, the 1, and the 8 are significant figures. And this number right here, 1.26, there's also times 10 to the minus 19. The times 10 to the minus 19 just tells you where the decimal is. That is nothing insignificant about that. There are only 1, 2, 3 significant figures for that number. And I guess I'll come back and underline all of these. 1, 2, 3, 4. Okay. Coming down to rule number 2, zeros to the right of the first non-zero number and to the right of the decimal point are significant. Other zeros are placeholders and are not significant. And to be clear, always use scientific notation. Well, let me show you what those mean. In this first example here, I have 2 zeros, and they are to the right of the first non-zero number, and they are also to the right of the decimal point. So they are significant, and I'm going to underline them. There are 3 sig figs. In the number I've got right here, I have only 2 sig figs because these zeros over here do not follow rule number 2. Okay. And so the short answer is there are 2 sig figs for this number. And if I write this in scientific notation, so let's say this, these zeros are going to disappear. So let me write it in scientific notation. 6.9 times 10 to the minus 3, where the minus 3 comes from the fact that I'm moving it 1, 2, 3 decimal places. So see this now? Oh yes, very clear. Well, hopefully somewhat clear anyway. 2 significant figures. This number down here has 4 sig figs. And you see this number here, 51,000 fans. So 51,000 fans may be like a number of people who attended a Washington does not have a name football game. And you're like, well, is there really 51,000 or did they just estimate that? Well, so here's what I want you to do. So first off, 51,000 fans is ambiguous. Meaning that we can't tell how many significant figures it has. But if I write it as 5.1 times 10 to the 4th fans, then it becomes clear. All becomes clear for how you're reporting answers and numbers when you put it in scientific notation. Now this number has 2 sig figs. We're reviewing sig figs now, but I just sort of introducing them actually. We will talk a lot about sig figs in lab. And we'll talk a little bit more about sig figs now. So 5, exact numbers or definitions have infinite sig figs. For example, there are only 7 days in a week. Have you ever gotten to a week and there were 7.3 days? No, because I mean, it'd be nice. You know, sometimes I wish there were 25 hours in a day, but there's only 24. So 1 week equals exactly 7 days. There's no wiggle room there. There's no error. That's what I mean by exact numbers or definitions have infinite sig figs. It's like saying 1.00000 dot week equals 7.0000000 dot days. There's no error in that. That's what I mean by infinite sig figs. How to tell a definition? They almost never have decimal places. Look, no decimal places in 1 meter equals 100 centimeters. No decimal places in 1 week equals 7 days. However, there's one definition that has decimal places, and that is 1 inch equals 2.54 centimeters. Now, I asked you to print them out. It's okay if you didn't. But if you go to the syllabus and a schedule section, you'll see something called the conversions and equations sheets. And look, right here on here, 1 quart equals a number of milliliters. Oh, there it is. 1 inch equals 2.54 centimeters. So during exams, during homework, I suggest that you print out all of these pages and have them to study from. And so you can see there's 3 or 4 pages there. But you are allowed to use those for exams. In fact, I will assume you are using those pages for exams. Now in lab, it'll also be important that when you do a division problem or a multiplication problem that you know how to keep track of sig figs. For a multiplication and division, the answer has the same number of sig figs as the number in the calculation with the fewest sig figs. So let me do by example what that means. The top number has 3 sig figs. The bottom number has 4 sig figs. Fewest sig figs in this problem is 3. That means our answer has 3 sig figs. So when we do the math, which is 56.1 divided by 12.01, we get a number that has so many digits. But we are only going to record the first 3 of those, 4.67. And with units canceling here, the answer should also have units of moles. We're not so worried about the units right now. Let's see, I've got a couple pages. I've got 2 pages left, and then will be time for another break. Here I have 2 sig figs. Here on the bottom I have 7. So our answer will only have 2 sig figs. So let me do the math part now. 1.2 divided by 1,674,295. I get 7.2. Well, I get 7.16, but it rounds to 7.2 times 10 to the minus 7. And those should be grams per milliliter. One more. On my top number, I have 3 sig figs. It looks like my bottom number has 60 minutes per hour. And 60 minutes per hour is a definition. from the previous page, remember, definitions have infinite sig figs. So this definition has infinite sig figs. And that's important because if the bottom number has infinite sig figs and the top number has 3 sig figs, 3 is less. So when I do this math, it will be 47.6 divided by 60, 0.7933333333. We're only reporting it to 3 sig figs, 0.793. And with canceling units, the units should be hours. One more page. That's for addition and subtraction. For addition and subtraction, the answer of the math has the same number of sig figs as the number in the calculation with the fewest number of decimal places. Let me show you, stack them up. When you did math, when I first learned how to do subtraction, the way that I learned how to do subtraction was by stacking them up. And so let's read through this problem and I'll show you. Initially, the burette reads 0.16 milliliters. After adding water to the beaker, the final burette reading is 21.67 milliliters. What volume of water has been added to the beaker? Well, it's the difference between these two. So it's going to be the difference or subtraction, 21.67 minus 0.16. This is what I mean by stack them up. You can still do the math on your calculator, 21.67 minus 0.16. I get 21.51. But you'll notice that the fewest number of decimal places is 2 decimal places. The fewest number of decimal places is 2 decimal places, and that means that your answer also has 2 decimal places. Your answer also has 2 decimal places, and that means that this is our final answer. Even though this number only had 2 sig figs, the final answer has 4. This last one's going to be a companion problem, and I don't know about you, but I'm ready for another 5-minute break. We'll be back at 10:50 this time, and then we'll do more. We're already on page 22, so we're making good progress. And I did not get to finish my snack last time, so I will be snacking this time. So I'm going to turn off my video for a minute.